Okay, that's really loud. Okay, so let's go ahead and take a look at that video review that we talked about. So keep in mind that in our opening problem, we've got this person that's 5.75 feet tall, standing 5 feet away from the foundation of the house. Now, keep in mind the siding kind of goes like this. This is a silly problem. The thickness of the house is just insanely big, and then it says that this is 1.5 feet thick. So it's like some massive like straw bale house or something like that. And we want to know how big that foundation is. So of course, if we did the ratio of the person's height is to their distance, it would be the same as the depth of the concrete would be to the thickness of that. And so if you quickly cross multiply, you're going to end up with x being 1.725, which is a pretty simple little idea. Now, in problem number 2, this is actually a very, very tricky little problem, because when you look at these triangles, the one on the left side right here has a 90 in it quite clearly, and it also has angle A in it. But if you look at the larger triangle, which I'm going to highlight in red, maybe like this, it also has a 90 in it up at the top, and also has angle A. So you can kind of see that the big triangle is similar to this triangle. And similarly, you could also make the same argument that the big triangle is similar to the green one, because they both have a 90 in them, and they both actually share angle C. So as it turns out, all 3 triangles are similar to each other. So if all 3 are similar to each other, that means the yellow one and the green one are similar. So as a ratio, the ratio of 3 to 10, so I kind of did short leg is to long leg. As in the green one, the short leg is to the long leg. Of course, a quick cross multiply leads us to the answer that if 3x is 100, then x is 100 over 3. Okay, moving on to our little fun stick figure shadow problem, that we have this 18-foot tree casting a 27-foot shadow, and our nice tall person that's 6.25 feet tall casting some unknown shadow. So of course we can set up the ratio that the height of the tree is to its shadow as the height of the person is to the person's shadow. And I did leave a little bit of a gap here, because sometimes before I ever start the problem, I will reduce it if I can. And you'll notice these are both nicely divisible by 9. So rather than dealing with 18 and 27, I dealt with 2 and 3. So again, a quick cross multiply leaves 2x equals 18.75, or x is 9.375 feet. Awesome. Now, number 4 is one of my favorite kinds of problems, because if we know that this entire zip line right here is 14 feet long, then what we know is we could call this part x, and we could call this part right here 144 takeaway x. And that allows us to say the ratio of the 2 heights, 81 to 27, is the same thing as the ratio of their distances. And there's a whole bunch of different ways that you could approach this problem, but this to me is the easiest. And I know that I can set this ratio up because they're similar, because these are alternate interior angles and these are vertical angles. So they're similar by AA. That allows me to say they're also proportional. And just like this previous question, I'm going to go ahead and reduce the fraction before I cross multiply. And the reason I set up the ratio that I did is because I could see that it would reduce nicely. And if you do, again, a nice little cross multiply, 432 minus 3x is x. Add 3x to both sides, and x becomes 108. And I think in the problem, it asks what is the length of x and y. And of course, if x is 108, and that would be this, then this is 144 takeaway x, that would be y is 36. And as we discussed in class, since this is a 3-to-1 ratio, then this one right here should also be a 3-to-1 ratio. And in fact, you'll see that it is. 36 times 3 is 108. Okay, moving into the next page. Now, we did this one in class, so we should be good to go. But again, these are not exactly similar triangles, but they're proportional pieces, because anytime parallel lines get cut by transversals, it actually cuts them proportionally. So the ratio of 14 to 12 is the same as the ratio of 21 to x minus 5. Now, of course, like each of the previous problems, you can solve it this way, or if you wanted to, we could go ahead and reduce first. And that definitely makes the solution a little bit easier to solve if we go ahead and reduce. So some of you would choose to cross multiply, and I get that, but I'm going to actually use a slightly different thing right here. And notice that this triangle right here, or this is 3 times as big, so x minus 5 has to be 3 times as big as the 6. And so, again, feel free to cross multiply if you see that, but I saw the equivalent fractions. And now if x minus 5 is 18, that's this piece right here, so km. Now, again, I could have plugged in 23, but I also saw that this was x minus 5, and so km is 39. Now, in class on number 6, and I think this will be the last one for this particular video, when I did this, the problem had a 27 here and a 54 here, and I decided that I'm going to do like a little ratio of similarity thing and shrink everything. So I'm going to do this whole problem by dividing every single piece by the number 27. So for the moment, I'm going to pretend that we are talking about a number 1 and 2. So hold on, I got a phone call coming in. I'm going to pause. Okay, we're back. That's so weird. Okay, anyway, I don't know if you can hear on the video that now announces things being recorded. So anyway, just like the previous problem, the ratio of x to h, again, short leg is to the long leg, 1 over h is the same thing as the long leg, short leg is to the long leg. Now notice that I did this using 1s and 2s instead of these. So h squared is 2, making h square root of 2. Now again, this isn't real because I should, if I call this root 2, we should know that the real value of h is 27 times as big. So keep in mind, I'm playing with these numbers in a smaller way. Now I could also find b, and I think I'm going to choose to go, well, okay, I think I'll show you the right way here. But in this big triangle right here, notice that the short leg is 1 and the long leg is b, and the long leg is, hypotenuse, I should say, is 3. So if I said b is to 3, and then if I redid that and I looked at this one, that would be the same as, so again, the short leg is to the hypotenuse, b is to 3, as if I look right here and I said the short leg is to the hypotenuse, that gives me again, b squared is 3 or root 3. Again, we shortened it a lot. So it'd be 27 of those. Now, some of you would have probably chosen to do that in a slightly different way. So for the last part, A, I'm going to go ahead and go the other direction, and let's use the Pythagorean theorem. Because I know to find this hypotenuse, I could say a squared plus b squared is c squared. So a squared, that's that one squared, plus this one squared, which is 2, root 2 squared is 2, equals c squared. But in this case, c is the letter a, so whatever, it is what it is. So I got a squared is 6, making a root 6. But again, as we know, keep saying it, a then would be 27 of those root 6s because I shrunk the problem down significantly. Now, I guess I'll just go ahead and finish up this last one. The answer key that has been posted is done in a very strange way, so just bear with. But the way I personally would like to take a look at this problem is, since it says that this whole thing is 36 units long, then I personally like to set it up this way and call this side x and this side 36 minus x. And that allows me to set up a nice little ratio. So the ratio that I see is the height is to the height, 12 is to 4, which again we can reduce as I've tried to influence this whole video. The height is to height as the base is to the base. And a quick cross multiply leads me to the answer. Add x to both sides, that x is 9. And I believe in this thing, it says how far is point D away from point C? So that means the value CD would be 36 minus 9, or 27. And I'm going to skip these particular problems because there's just a picture of them in the notes. And so I will be back for problems 9 through probably 15 or 16. Okay, see you in the next video. Bye-bye.